All right, folks, we're done with page 2. Let's jump into page 3 now. And really, this page is about the sampling distribution of x bar 1 minus x bar 2. We have one example here. It's about potato chips. Let's go ahead and take a look. A chip manufacturer buys potatoes from two different suppliers. We got Riderwood Farms and we got Camberley Inc. The weights of potatoes from Riderwood are approximately normally distributed with a mean of 175, standard deviation of 25. Weights from Camberley are approximately normally distributed as well, with a mean of 180, standard deviation of 30. When shipments arrive from the factory, the inspectors randomly select a sample of 20 potatoes from each shipment, and they weigh them. So let x sub c bar minus x sub r bar be the difference in the sample mean weight of potatoes from the two suppliers, where that is the mean weight of the sample of 20 from Camberley, and that is the mean weight of the sample of 20 from Riderwood. Okay, so now I mentioned that this was about the sampling distribution of x bar. Here's why. We're asked to do a couple things here in this example. First, we're going to look at the shape. We're going to look at the center. And then we're going to look at the spread. And we know that that's how you describe a distribution. So let's describe the sampling distribution of x bar c minus x bar r. The shape, well, that's going to be normal. So we don't have a large sample here in either case. Each sample is 20, but the problem states that each population is approximately normally distributed. So the sampling distribution of x bar, x sub c bar minus x sub r bar will also be approximately normal. Okay, just a couple quick comments here, and I'm just kind of capturing information that's given in the problem. For Riderwood, we know that that's normally distributed with a mean of 175 grams and a standard deviation of 25 grams. That's the population parameters of mu and sigma. And we have a sample size there for Riderwood of 20. For the other supplier, Camberley, it is also normally distributed, but we have slightly different mean and standard deviation, but we have the same sample size. Okay, let's now talk about the mean. The mean of the sampling distribution is quite simply this. The mean of the sampling distribution of x sub c bar minus x sub r bar is equal to the difference in means of the two populations. And that is 180 grams minus 175 grams for a net of 5 grams. So that means we expect if we take the mean of two samples and subtract them, that difference should be 5 grams. Okay, that's the center. Let's now move down to spread. Find the standard deviation of the sampling distribution. Show your work. Well, here's our formula. And that results in an approximate standard deviation of 8.732. All right, now let's do a quick little application here. What is the probability that the Riderwood sample mean is larger than the Camberley sample mean? Well, in order for that to occur, if the Riderwood sample mean is greater than the Riderwood sample mean is greater than the Camberley sample mean, then x sub c minus x sub r bar should be less than 0. Well, remember, what we have here is a sampling distribution of that statistic x sub c minus x sub r. So that sampling distribution has a mean of 5 and a standard deviation of 8.732. We calculated those values in the previous part of this problem. So if that mean is 5, and we're interested when the difference in those two statistics is less than 0, that means we have to find this shaded area right here. And that's going to be a normal CDF calculation. The probability that x sub c bar minus x sub r bar is less than 0 is equal to normal CDF, lower boundary of negative infinity, upper boundary of 0, mean of 5, standard deviation of 8.732, and we get a value there of about 0. Okay, the dogs are really, really excited about that. The probability of the Riderwood sample mean being larger than Camberley sample mean is about 0.283 or 28.3%. Okay, folks, that's it for page 3. Stay tuned in a few minutes for page 4.